Hello everyone. So without wasting time, let us start today's session with this question. The question is from chemical bonding. So which of the following overlapping is incorrect, assuming Z axis as internuclear axis? So we have to consider Z axis as internuclear axis. So consider this one is Z axis. Now if we consider pz orbital will be along Z axis. So this is pz orbital. Let us consider another pz orbital. They are along Z axis. If the sign of the wave function are same, then they will overlap, constructive overlap. So if along Z axis they overlap head to head, then pz orbitals will overlap head to head. So that's why it will form a sigma bond. So it will form sigma orbital. Okay. So option B is correct. PZ it will form sigma. So we have to find incorrect one. Okay. We have to find incorrect one. Remember. So PZ will form sigma. Now if this is Z axis, if we consider px or py, so they will be perpendicular to this Z axis. So px or py, if we consider, both will be perpendicular to this Z axis. Now if they overlap, there will be lateral overlapping. In that case, we will get pi bonds. So if it is px or px overlapping, then it will be pi bond. Py overlapping, it will be pi bond. So here we can see A py overlapping pi bond, px overlapping, it is pi bond. So these are correct. So only incorrect option here, that is D. So the correct answer will be only D. Now consider how D is incorrect. So we have one s orbital and py orbital. So again, this is Z axis. We have 1s orbital. So 1s is spherical. So this is 1s orbital. Now if you overlap py, that is perpendicular to this axis. Perpendicular to this axis, that is py. So consider the sign of wave function is plus here, it is plus, it is minus. Now this one will be constructive overlapping and this one will be destructive overlapping. So overall in this case we will call zero overlapping. In this case it is zero overlapping. So zero overlapping, it will not form any bond. So this is the wrong one. Okay, I hope it is clear. Next, see question number 2. So question number 2, it is directly from the lines of NCERT. So many transition metals from interstitial compounds. The characteristics of these interstitial compounds are. So let us see from NCERT. It is written here. The characteristics of these compounds are follows. So here number 1, you can see they have a high melting point, higher than those of pure metal. So melting point will be higher. They are very hard. Some borides approach diamond like in hardness. They retain metallic conductivity and they are chemically inert. So these 4 points you have to remember that are characteristics of the interstitial compounds. Now if you see the question, many transition metal form interstitial compounds. The characteristics of these interstitial compounds are, the first option here we have, they have very high melting point, higher than those of metal. So this one is correct. They are very hard. This one is also correct. They retain metallic conductivity. That is also correct. They are chemically inert, chemically more reactive, they are saying. So this is incorrect one. So this is incorrect. So we have to find the answer. The characteristics compounds are, so 1, 2, 3. These 3 are correct. Again, you can see here the points, they are hard, their melting point. Okay, so their conductivity is the retain metallic conductivity. So remember, this one is important. Okay, so I think this is directly from the NCERT. You can relate that one, read that one carefully. You'll see this type of questions in your exam. Next, see question number 3. In this case, we have to find the value of x. So to solve this question, you have to know that that ionic potential, if ion, metal ion, cation, they have more ionic potential, there will be more crystalline water. So you have to consider the ionic potential of the metals. So ionic potential is directly proportional to charge on the atom, charge on cation, and inversely proportional to size of the cation. So charge by size ratio, if charge by size ratio is higher, then the x value will be higher in this case. So you can see in this case the answer will be this one, because magnesium, it is +2 charge and it is the smallest one. So that's why in this case the answer is 1. Let's see question number 4. Question number 4 from solid state. Very important question. In a face-centered cubic arrangement of A and B atoms, whose A atoms are at the corners of the unit cell and B atoms are the face centered. So if we consider A atoms, the total A atoms will be 8 corners, 8 into 1, 8, total A atoms will be 1. And B atoms, there will be 6 faces, and each face atoms contribute half to the unit cell. So there will be 3 B atoms. One of the B atoms is missing from the face, one face. So one B atom will be missing. That means we have to remove half, because B atoms are present at the face. That's why only half of the B atoms will be removed. Then new formula. So it is 5/2. So the new formula will be A B 5/2. A1 B 5/2. If we simplify that one, that will be A2 B5. So that is the answer, A2 B5. So 3 is the correct answer. Okay. Last question, problem 5 from organic chemistry. SN2 reaction will be negligible. So in this problem, we are given 4 different halide bromide. We have to find the which one will not participate or less participate in SN2 reaction. So remember, in this case, this bromine, lone pair of bromine can participate in resonance, and that's why this bond, this BRC bond, will get a partial double bond character. So that's why this bond will be difficult to break. So it will generally do not participate in SN2 reaction. In second case, you can see this carbon, this alkyl halide is 3 degree. Again, this back side is blocked by this carbon atom. So this carbon atom blocks the backside attack of the nucleophile. So this will also not participate in SN2 reaction. Third case, again partial double bond character. So it will also not participate in SN2 reaction. So the answer in this case only that can participate in SN2 reaction, that is number 4. So in this case the answer will be 1, 2 and 3 not react in SN2 reactions. I hope that is clear to you. So thank you very much for watching this video. If you like this video, please subscribe and hit the bell icon. Then you will get the instant notifications of our upcoming videos. Thank you once again.